Hello, how are you all? Okay, so today we are going to continue on exercise 23. Okay, so first of all, we're going to read the question. There are some squares and triangles on the table. Some of them are blue and the rest are red. Some of these figures are large and the rest are small. Okay, before what we know, let us draw them. So some of our squares are blue and small. I'm going to draw one small, one big, and triangles, one small, one big, and then we're going to add the red one. So I have small one red and big one red. Also the same for the triangles. So small triangle red and big triangle red. Hopefully we can use our figures to know everything. We know that in the figure, if the figure is large, it's a square. So whenever it's large, it will be square. So this figure is large, but it's triangle. So of course, we can take it off. And this figure is large, but it's a triangle. So also, we're going to take it off. Now the next one, if the figure is blue, it's a triangle. So no need for squares, blue squares. Whenever it's blue, it will be a triangle. Whenever it's large, it's a square. So which of the statements A to E must be true? Let's go into each one alone. First one, all red figures are squares. So red and red, but I have this one left after deleting according to my given. So need to cross it out. All squares are large. Okay, I have a small square. So of course we're going to delete it. All small figures are blue. No, I have small figures, but this one and this one are red, not blue. So also we're going to delete it. All triangles are blue. No, I have one blue here and I have a red triangle. So also I'm going to delete it. So if this one was not right, of course, we have a mistake. Let's read it. Okay, all blue figures are small. Okay, so this one is small. I don't have anything left. Yes, blue I have only small triangles and they are small. Yes, so this one must be true. Okay, so I will repeat this one, the easiest question in the 5-point problems. Okay, the algorithm here, this one is for logic. So we have the best, don't ever make it a complex problem. So if it gives, it's a square. So if it's a square, doesn't mean it's large. If the figure is large, it's a square only. It's implication, not equivalent relation. Okay, so don't get confused with equivalence. Now, the thing we did here is I have some squares and some of them are squares and some of them are triangles. So I draw squares and triangles. Some of them are blue and the rest are red. So let's make one blue, one red, one blue, one red until we found the general shape, okay? And then apply the conditions. If the figure is large, so I'm going to search for all large figures, this one and this one, this one, this one. I have 4 general shapes. It's a square, so no need for triangles. I can cross them out. If the figure is blue, so these 4 are blue, it's a triangle. So I can cross out the squares. I'm left with this small triangle, and this small square, and this big square. So we're going through each choice alone. All red figures are squares. Let me suppose it's right. We're going to search for red figures. We have these 4 left. All of them are red. These 3 are red. So all red figures are squares. No, I have a triangle here and it's red. And the conditions didn't cross it out. So I need this choice to be crossed. All squares are large. So of course we're going to see no, we have 2 squares, one small and one large. Of course we need to cross it out. All small figures are blue. So I have this small, but this one is small and this one is small and both they are red. So of course not. All triangles are blue. No, I have one blue and one red, but all blue figures are small. So look at this. This one is the only one left blue figure and it's small. So yes, this is my choice. Okay, this one is easy question, so we solve it quickly, but this one needs a lot of work. So let's start reading it. 2 identical rectangles with side of length 3 centimeter and 9 centimeter. So of course, this one will be 3 and this one will be 9. We're going to use the figure, that's why I made it far. Now, are overlapping in the diagram. So of course, you know, from the diagram, it's clear for us what happened. What is the area of the overlap of the 2 triangles? Okay, so I'm going to search for the area of the shaded part. First of all, I know the area of the rectangle. It's equal to 3 multiplied by 9. So of course, it's equal to 27 centimeter square. Of course, this area must be smaller than 27. We're going to our choices and then we're going to cross any one above 27. Of course, all of them are small, so we cannot take any one out. Now, let's continue on how to solve it. It will take us time, but it can be solved. First of all, my plan here is we can see it clear. It's a parallelogram. Let's prove it first. It's a parallelogram. If we prove that a parallelogram, we have the rule how to find the area of a parallelogram. And of course, we can find the area of triangles and subtract it from 27, which is the area of the rectangle, and we are left with the parallelogram. Okay, so let's start. And we're going to use each property alone when we need it. Okay, now, first of all, I have a side I need to know in order to find the area. I don't have it. It's something less than 9, but I don't know the exact value. First of all, you may think that this one is half of the segment. Of course not, because if it was half of the segment, then I'm going to draw a perpendicular line And of course, it's not passing through 2 points. It passes through 1 point only. So no, it will be never half of it. Another plan, let's prove it's a parallelogram in order to prove that this one is equal to this one equals to this one. Simply, I can see that this side is parallel to this side because both of them are in a rectangle, and we have the property for a rectangle opposite sides are parallel. And moreover, I have that this side is also parallel to this side. So, because also they are a side of a rectangle, and it's a property for rectangle opposite sides are parallel. So by definition of a parallelogram, we have opposite sides parallel, then it's over. It's proved to be a parallelogram, and now we have all the properties, including opposite sides are equal, opposite angles, diagonals bisect each other, but I no need for this and no need for the angles. Now, let's give it a name so we can solve it. I'm going to call it X. So of course, if it's a parallelogram, then this side is equal to this side. Now let's change the color. Now I want to focus on this idea. We know that the area of a parallelogram is the base multiplied with the height. So I'm going to draw the height, and of course, any place here, it's equal clearly to 3 because it's perpendicular. This side is perpendicular, so it forms a parallelogram, and the same value opposite sides are equal. So of course it's equal to 3. So first of all, the area in terms of X of the shaded part is equal, we're going to denote it only by A, equals to 3 multiplied by the base, which is X. Clearly it's 3X. No need for writing 3 multiplied with X equals to 3X. We all know that. Next, let's continue. We have the value in terms of X. So now I need to find X. Okay, it's a problem, but we're going to find something to solve it. First of all, if you have two rectangles bisecting each other, let's imagine together. This shaded part, it's a part of this rectangle and a part of this rectangle. If you want, I'm going to call them with a different color. I'm going to write it down, rectangle 1 and rectangle 2. So, if we use rectangle 1, we're not going to waste time on it now. We're going to get the same result. So, of course, this is not what we are seeking for, but let's use rectangle 2. So, the area of rectangle 2 is 3 multiplied by 9, which is 27. The area of the shaded part is 27 minus the area of this triangle plus this triangle. So we're going to remove them both. Now, concerning the values, I know that this one is equal to 3. Also, this one is equal to 3 because it's a given. This one, all of it is equal to 9, but this one, it's not equal to 9. I need to know this one to subtract 9 from it. So let's find another plan. But before, we all know that we have 4 right angles, inside the rectangle. So maybe we can use it. As I can see clearly, this one plus this one squared plus this one squared is equal to x power 2, the hypotenuse square. So in order to make it real, I'm going to denote it by y. And I'm going to use Pythagoras. Now, y power 2 plus 3 power 2 equals to x power 2. Okay, so I need to find y in terms of x. I don't care about y because I don't want to make it a complicated one with two unknowns. So we are going to make our work only with x. Let's solve this equation in terms of y. Solve it for y. So of course y power 2 is equal to 3 power 2 is equal to 9. Now I can take 9 from both sides and I'm going to be left only with x power 2 minus 9. And of course, you know that y is equal to apply the square root. It's a plus or minus, but we are now dealing with sides. Length can never be a negative value. So of course, we're going to stick on the positive choice. And it's equal to square root of x power 2 minus 9. Don't ever take them off. Just remember the operation between them is subtraction. We can never do anything about it. It will remain inside. Otherwise, we have a case when they are multiplied. Of course, you can take them out, but here we have subtraction, so don't take them out. Now, let's continue. We have that the area of this right triangle is equal to side multiplied by side over 2. Let's write it with different color. I'm going to choose. I'm going to stick back to black. The area is equal to 3 multiplied by y, which is radical x power 2 minus 9. So, of course, it's a 3 radical x power 2 minus 9. And now let's continue over 2. This is the general rule. Now, this one, we need to find this one also. This one the same because we have y here and y here. 3 and 3 the same side. So, of course, we're going to multiply by 2 to get the area of two triangles. This one and this one. So simply we're going to divide 2 with 2 and we are left with this term. So the area of these two triangles is 3 radical x power 2 minus 9. Now, what about the area of the shaded part? So it's equal to this area minus these two triangles. I have these two triangles and I have the area of the rectangle. We talked at the beginning it's equal to 27 because it's given 3 and 9. So simply 3 multiplied by 9 is 27. So of course we're going to write it down 27 minus 3 radical x power 2 minus 9. So this area is equal according to this rectangle, and according to itself, we found that it's equal to 3x, and it's equal also to this term, 27 minus 3 radical x power 2 minus 9. So we are almost done. Let's change the color and start solving. We have this one for this area and this one for this area, so these two values are equal. That's our problem, and that's what we are going to do to find the value of x. So we can use it to find the area. Okay, now 27 minus 3 radical of x power 2. Okay, I forgot the 3. X power 2 minus 9 is equal to 3x. We need to solve this equation in order to find x. Okay, first of all, when we are dealing with the square root, we need to get rid of it. And in order to get rid of the square root, we need to do power 2. But of course, not 27 minus 3 square root, because if we apply square to this equation direct, we're going to deal with a minus b. So a power 2 minus 2ab, which is 2 multiplied with 27 multiplied with 3 radicals. So I'm going to stick on radical. We didn't get rid of radical. So we are going to simplify and keep the radical alone, so you can apply the square directly. Now, in order to get rid of 27, we need to subtract from both sides by 27. And if you want, we can get rid of this term, negative 3 multiplied with it. So I'm going to divide after that with negative 3. So of course, I'll be left with radical x power 2 minus 9 is equal to 3x minus 27 divided by negative 3. Okay, before going deep into the square, always simplify, because when you don't simplify, of course, you will face a lot of troubles. Now, x power 2. Let's keep this one the same. I'm going to write it here. Radical x power 2 minus 9 is equal to, as you can see, we are dividing on two numbers subtracted from each other, not multiplied. So the 3 will be for both terms, not only for one. Okay? Please don't forget that. So 3 divided by negative 3 is negative 1. So negative x minus plus 27 over 3, 9. And now you can raise it to power 2 to get rid of the radical. If I raise it to the power 2, we're going to get rid of the radical here. So x power 2 minus 9 is equal to, so you can imagine it, it's 9 minus x, so as if I'm saying a minus 2ab plus b squared. So it's 9 power 2 going directly to calculate it, which is, of course, you know it, 81 minus 2ab, so 2 multiplied with 9 is 18, and don't forget the x, which is b, plus b power 2, so x power 2. Now, when you see this, you will be complicated. It's a quadratic equation. It's not a linear equation, so it's hard to find. I need to find delta, etc. No, simply you can see that I have two positive terms. Any number power 2 is positive, so of course I have two positive terms. And of course, don't forget to add condition when you are calculating that x is not equal to 0 because I divided with x power 2. So when I divide, when I take them off, I subtract it. No need for this condition. Okay, I subtracted by x power 2, so of course I'm left only with negative 9 equals to 81 minus 18x. Now it's a linear equation, we can solve it. Simply we need to exchange the signs. So I'm going to multiply with negative 1, and then we are going to keep the x alone and the numbers on one side. Let's start by exchanging the signs. So it's 18x minus 81 is equal to 9. Now we can solve it. First of all, we're going to add 81 to both sides. So 18x is equal to 81 plus 9, which is 90. So divide both sides by 18, x is equal to 90 over 18. So finally, x is equal to, using our calculator, 90 over 18 is equal to 5. Or of course, you can find it simply with that long division. So of course, using this way, we found x. X is equal to 5. So this side is equal to 5. But the real question is, it's not about x, it's about the area of the shaded part. We know that the area is equal to 3x or 27 minus 3 radical x power 2 minus 9. Of course, we're going to choose the easiest one, the simplest one. If we took out x and put 5 instead, we're going to have that the area of the shaded part is equal to 3 multiplied by 5, which is equal to 15. No, remember, don't forget the unit, centimeter over 2. So of course, it's not this these three. Okay, not this one, this one. Okay, so this is how we can solve this problem to find how much the area of the shaded part. I'm going to repeat it. All of you, you must know the algorithm, how we solve that problem, and how we think that these steps, all of you, you know how to calculate them, you know how to undergo these steps, but it matters about the plan. So the plan, first of all, is the most necessary one. Now, sorry, the most important. Now, I'm going to make a small quick revision on it. We have that two identical rectangles, so 1 and 2, and of course they are overlapping as you can see here, and of course this shaded part, they need the area of it. They told that this side is equal to 3 and this side is equal to 9. Concerning this side, it didn't mean a lot to me, but of course, if you didn't memorize, if you didn't prove that this is a parallelogram, you are going to use it because you have to find this side, which is 9 minus x, and you will go under harder equations. So I think this one is better. Now, first of all, we plotted 3, 3, 3, okay, and I know that these two are parallel and these two are parallel, so of course we are dealing with a parallelogram. It's proved, so opposite sides are equal, so this side is equal to this side. I gave it the name of x, and of course we know that x is bigger than 0 and smaller than 9, because all the side is equal to 9, so of course it's smaller than 9. Now, what I need to do is the following. First of all, we found the area of this shaded part. It's equal to simply the base multiplied with the height, which is x multiplied with 3. So I'm dealing now with 3x. So the area simply is equal to 3x. Now, logically, we need to find another equation to solve x, because we don't have the value of x. And in our choices, there is nothing about x. So, of course, we calculated the other one using the other triangle. The area of the shaded part is equal to the general area, all of it, minus the area of this triangle and this triangle. So simply, we found this one. We don't have this side. We gave it the name of y. I know that there's a right triangle, so we're going to use Pythagoras. So 3 power 2 plus y power 2 is equal to x power 2. And then we solve that for y. We got this answer. So of course we can replace y here with radical x power 2 minus 9. Now we moved on. The area is equal to this multiplied with 3. Let me change the color. Okay, so this multiplied with 3 over 2 is this area, and this multiplied with this over 2, also this area. So, of course, there's 2 up and 2 down. We can simplify because we need 2 areas. Now, the area of this and this is equal to 3 radical x power 2 minus 9. And the area of all the rectangle is equal to 27. So, of course, the shaded area is equal to 27 minus 3 radical x power 2 minus 9. And of course, this is the area of the shaded part and this is the area of the shaded part. So they are equal. And we put them down and then we solve simply. 27 minus 3 radical x power 2 minus 9 equal to 3x. We have radical. We need to get rid of radical in order to solve equations. We cannot solve when the radical is there. We need to get rid of the radical and then go into the problem. Now, we wanted to raise it power 2, but we can't now because it will remain there. We need to keep it alone. So I subtracted by 27 and divided by -3. As you can see here, okay, so at the end we are left only with this. We raised them both power 2, and then we got 18x. It's the inverse, but the opposite. But of course, we switch the minus by multiplying with -1, of course, or dividing with -1. So 18x minus 81 is equal to 9, and then it's a simple one. We solved it and we found that x is equal to 5. Then going back, I'm sorry, I went too much back. Okay. The area is equal to 3x or equal to this one. We can use any one we want. Of course, we are going to use this one because it's more simple. So area is equal to 3 multiplied by 5 equal to 15 centimeter squared. Or of course, if we use this one, we're going to write 27 minus 3 of radical 5 power 2, which is 25, minus 9, which is 16. So radical 16, we all know it's equal to 4. 4 multiplied with 3 is equal to 12. So 27 minus 12 is equal to 15. So the area is equal to 15. But here, it's much easier for us. And of course, if you know that we don't have enough time, so of course you are going to choose the easiest way. Now, going into question 25, we're going to read it and we're going to underline what we need from the given. Ahmed labeled the vertices of a square-based pyramid. So of course it's a pyramid and the base is square. Okay, as you can see, I have 1, 2, 3, 4 surfaces. I'm dealing with four sides, 4 triangles, and I'm dealing with, of course, down a square base. Okay, so what should I understand from here? Using 1, 2, 3, 4, 5, once each. So he labeled the vertices. Maybe 1, 2, 3, 4, 5, I don't know how. For each face, Ahmed calculated the sum of the numbers on its vertices. 4 of these sums equal 7, 8, 9, 10. What is the sum of the fifth face? Okay, so to be honest with you, usually when I'm dealing with these problems, I always put the numbers, the bigger numbers down. So of course, if I have here, for example, I need the bigger are 4 and 5. So I put them down. So now, as you can see, I'm going to change the color, it's not clear. Okay, we are left only with 1, 2, 3. So I have vertex here, it's from the back, and I have one here and one here. So how we will put the vertices? Okay, so there's nothing to do about it. You need to try. Okay, so of course, if I put it the 1 here, the 2, and the 3, there's a lot of choices, but always fix down the bigger ones. Now I have 1, 2, 3. Let us add the surfaces. Okay, so 3, 5, 8. 5 plus 3 is 8, 9. I have 9 in my domain, I'm fine. 4 plus 3, 7. Plus 1, 8. Also, I'm fine. I need 7 and 10. 4 plus 2, 6. Plus 1, 7. Okay, so I need 10 also. 5 plus 2, 7 plus 1, 8. No, I have 2 8s. So this one is 8, this one is 8. The one from the back and the one in front. So it's a wrong choice. Now let's change the order. So imagine it like a circle. I have 1, I have 2, and I have 3. 5 plus 2, 7, plus 3, 10. Great. We got the one was missing and the previous one. 5 plus 3, I'm calculating now this one. 5 plus 3, 8 plus 1, 9. Great. 4 plus 3, 7 plus 1, 8. Also great. And the last one, 7 plus 2, 9. Now we did use that. Now let us change the order also. So I'm going to put the 2 up. And 3, 1. So 1, 2, 3. 4 plus 1, 5 plus 2, 7. Okay, the smallest one. 5 plus 2, 7 plus 1, 8. Also this one. 5 plus 3, 8 plus 2, 10. So I need this one to be 9. If it's 9, I'm fine. 4 plus 3, 7 plus 2. Yes, it's 9. So I got it right. Everything here. What is the sum of the fifths? Phase, so I'm going to add the sum. 5 plus 4, 9, plus 1, 10, plus 3, 13. So I'm going to choose 13 type. The problem here, I can do nothing. A lot of work here. As you can see, 5 plus 4, 9, plus 3, 12, plus 2, 14. So of course, I can take off this one, but I'm left with 4 choices. So it's a 25%. If I choose like any one, so it's 25%. No, we don't need that risk. Okay, let's repeat the work done here. So we didn't do so much work, so much effort. I only fixed 5 and 4 down because all the choices are above these choices. So of course we are going to calculate the sum of the square, the vertices in the square, because we have 4 vertices up, we have only 3. What I did here is the following. I fixed 4 and 5 because they are the 2 bigger numbers, and then I played with 1, 2, 3 as a circle. So once 1, 2, 3, and the other time 2 up and 3, 1. And of course, we're going to test 3. And of course, there's 3 cases left. We can keep the 2 here and switch 1 and 3. But of course, nothing will change. So we are not going to test this choice. Because if we only took 1 from here, put it here, and switch them together and 3 and so this face will be equal to this face in another way. So we don't care about the same case. Now we added 4 plus 2, 6 plus 1, 7. We can find we have this 5 plus 2, 7 plus 1, 8. Also we have it. 5 plus 3, 8 plus 2, 10. We have it. We need 9 also. 4 plus 3, 7 plus 2, 9. So we are fine. Now we can simply add these 4. So 4 plus 5 plus 1, 10, plus 3, 13. Okay, so this is how we found this answer. Let's move on. On 26. Okay, a large cube is built using 64 smaller identical cubes. Okay, so I have 64 cubes consisting the large cube. We are fine. Before moving on, just all of you, I want you to focus on this idea. If I have a cube consisting of smaller cubes, I can call these smaller cubes to be the unit cubes. Okay, as if I'm talking about centimeter cube. So this will be our unit. 3 of the faces of the large cube are painted. Okay, what is the maximum possible number of small cubes that have exactly one face painted? Okay, they need us to work a lot, but we're going to draw our figure and then we're going to find the answer, the right answer. Of course, if you want to draw the cube, I will have this one, this one, this one. These sides are in front. Oh, I'm sorry, no need for this one. You can erase it. Okay, so as you can see, this is our cube, and we are going to do our work on it. So, first of all, we know that it consists of 64 small cubes, or in other word, I'm going to call it unit cubes. So, 64 U. Now, there's 64 inside, so the volume of this cube is 64 U. Okay. What is the rule used for finding the volume of a cube? Of course, the side of a square, let's call it S because we don't know it yet. And it's power 3. It's equal to the volume of the square. And we know that it's equal to 64 U, so S power 3 is equal to 64. Of course, there's radical versus 3. And if you don't want to go through that, it's easily found on calculator here. But if you don't want to do that, search for a number, multiply 3 times, and it's equal to 64. Simply you can start with 3. For example, 3 multiplied with 3 is 9. Multiplied with 3, 27. So no, it's not our choice. 4 multiplied by 4 is equal to 16. Multiplied by 4 is equal to, for the 10, I have 40, and for the the 6, I have 24. Add them. They are equal to 64, sorry. So simply the answer is 4. Or you can use your calculator and find the value directly. So now I know that this one consists of 4 squares. The side consists of 4 squares. Each side consists of 4 squares. So I have like this 1, 2, 3, 4, and like this. So each face consists of 16 squares. Okay, we're fine now. Let's continue. What is the maximum possible number of small cubes that have exactly one face painted? So, maximum number. Focus on this word. They asked for the maximum number. So, of course, we can choose a lot of different faces and we are going to obtain different numbers. That's the reason why they asked about the maximum. Now, in order to understand this trick, the maximum number, so if we choose consecutive faces, we are going to have square, for example, here, face in this face, and the other face will be in this face. So two painted, of course, it's not included. So this is the reason why they asked us for the maximum. In this case, I'm going to take another one, take the one opposite to it. The one that I can't see because it's behind. And take, I don't have a lot of choices. I have the up and the right, the left, and the down. So all of them are intersecting with them. But of course, it's different if we took, for example, this face and this face and the face down or up. We have a lot of intersection there. We have a lot of common squares sharing with two faces. So, of course, we are not going to choose a lot of sharing stuff. So, I have this one, maybe I'm going to through the right. It's up to you. You can do this or this or this. It's fine. Now, if we look deep, if we painted these surfaces, okay? Now, this one is not painted from here. So this square is included. Only one face is painted. 1, 2, 3, 4. Count them. These I have 4 also. And these I have 4 also. So till now I have 12 squares painted. We are fine till now. Let's continue. I have 1, 2, 3, 4, but these 4 will be painted with this face, and of course the same square will be here in the edge, on the edge. Okay, so we can take it off. We have 4 different columns, so I'm going to ignore one. We are left with 3. This one, of course, there's nothing common with the other one, and this one also. So I have 2 columns to multiply with 4. It's 8. The fourth one, of course, it's sharing with this one. So I'm going to take it off and I'm going to take the first one. Let's draw it like this. Hopefully all of you understand what we are doing here. We have 1, 2, 3, and 4 columns here. So I'm going to cross this one because we crossed already this one. And now we are left with 3 columns. Okay, so there's nothing sharing with the other faces. So of course the 3 multiplied with 4 is 12. So also I can add 12. Okay, so 8 plus 12, 20, plus 1, above plus 10, sorry. 30 plus 2, 32. So yes, this is my answer. Okay, we are going to repeat it. A large cube is built using 64 smaller identical cubes. 3 of the faces of the large cube are painted. So they paint only 3 of them, not all of them. What is the maximum possible number of small cubes that have exactly one face painted? So the trick here is simple one. Only consider the small cubes to be your unit cubes. So, as if we are saying, I told you centimeter square or cube, sorry. So it's my unit. I'm going to make it my unit. Now, the volume of this cube is equal to 64 unit. Okay? And I know that the volume of a cube is equal to the side power 3 because it's side multiplied with side to obtain the area and multiplied by this side to complete the partitions. So of course it's equal to S power 3. And so S power 3 is equal to 64. We can apply the radical or we can the try numbers, and we're going to obtain, it's up to you, and we're going to obtain S is equal to 4 units. So I have a square here, square here, square here, and square here. And of course it's repeated to all faces. Now, no need for drawing these. Going to erase them. And I'm going to change the color to explain it more. Now, the thing we did here is the following. The maximum stands for the main thing here, the main trick. The maximum number means maybe we were going to choose 3 faces and we're going to obtain a smaller number. So it's right to ask ourselves this question. As you can see, if we got, for example, 1 and 2, the one in front of us and the one on the right, with the one up, we're going to obtain these 3 are only one face, had only one face painted. The 3 also and 3. So I have 3 multiplied with 3, which is 9. These 4, all of them are painted more than once because this one will be painted 3 times. And of course, I have these painted, these painted, the above painted, so I'm dealing with 9, 9, 18. And up, we're going to get rid of these 4 to get also 9. So 9 multiplied with a 3, 27 faces, which is choice A. Of course, some of you will answer this, but it's a wrong answer. So what we did here is the following. We wanted to search for a choice to avoid the common squares among all faces. So we did this one and we took the opposite. You can choose this one and take the opposite. But when we took the opposite, we found out that we can't choose something else. There is something we'll be sharing with 2 faces, then it's fine. We are left with no choices. We're going to take this one or this or any face. Now, we count them. So I have these 4 units, yes, they have 1 face painted, and these 4 also, so we are dealing with 12 units. We wrote 12. These 4 are sharing with this face, so of course they will be painted on both faces and the unit square. So we're going to get rid of them. Now I'm left with 1, 2, 3 because the 4th column we took it out. 1 and 2 for sure they will be painted on one face, but the last one will be painted also on 2 faces, sharing with the other one, the 3rd one. So I'm going to take off this one, and I have 1, 2, 3, which is 12. 12 plus 12, 24, plus 8, 32. So I took this to be my choice, C. Okay, guys, Thank you all, and tomorrow we will continue on the rest. Okay.